Okay, so for the final page of this test, it says below are three systems of equations and three methods of solving them. Solve each system in a different way. Make sure you use all three ways. Show all your work and record your answers as a coordinate pair x, comma, y. So the first method that's listed here is the equal values method, and I think of the systems that I see up here, this is the one that I would choose to use with the equal values method, because you can see it's telling me that y is two different things, right? Y is 3x minus 4 and y is also 2/3 x minus 74. So what I can do is I can set those expressions equal to each other and then just solve for x. So I'm going to begin by go ahead and writing those equations down. The one side was 3x minus 4 was one of the y's, and the other one was 2/3 x and then minus the number 74. And my favorite thing to do is always to just push through a factor of 3 to clear these fractions. So every single term on both the left and the right hand side is going to pick up a factor of 3. Over on the left hand side, I begin with a 9 times x, and then I have a minus 12. Both of those terms were multiplied by 3. And then I have 2/3 x times 3 is going to give me a 2x. And then finally, minus 74 times 3 is negative 222. So cleaning this up a bit, I'm going to subtract 2x from both sides. That gives me 7x minus 12 equals negative 222. If I add 12 to both sides, that's going to give me 7x is equal to negative 210. And that's like 21, but I got to add a 0 on it. So 210 divided by 7 is going to give me x is the number negative 30. Okay, we're not done because we need to know what y is. And if we recall, there were two equations that told me, y is either 3x minus 4 or y is 2/3 x minus 74. So I'll go ahead and use the top one there. It says that y is 3x minus 4, but playing the role of x is going to be negative 30, so y is 3 times negative 30 minus 4. Y is negative 90 minus 4, so finally y is negative 94. So I believe that my solution is x is negative 30 and y is negative 94. Now it's worth just plugging those values in and then just verifying that it works. So in each of these equations, right, if I enter 30, I should get negative 94. And essentially I've checked the first one already, because when I put in the negative 30, I got 94 for that top equation. Let's check the second equation. So I'll just go 2/3, and I'll just multiply like that. 2/3 times, then I'm hitting that little negative symbol, not subtraction, but negative 30. So that's 2/3 times x minus, I'm sorry, 2/3 times negative 30, and then minus 74. And when I press enter, you can see it says negative 94 also. So that is definitely our solution. X is negative 30, y is negative 94. Next, let's find one that we can use the substitution method with. Probably we could do it with either one with some work, but probably this is the most straightforward. And I just say that because the top equation gives me this expression that is equivalent to y. So we're going to do that substitution. Let me go ahead and go down here and write it in the workspace. So using the substitution method, we had y is equal to 2x minus 1, and we also had 4x minus 3y equals 7. So let's see, y is this expression. So I'm going to rewrite this as 4 times x minus 3 times 2x minus 1, and that equals the number 7. So 4x minus 6 times x and then plus 3. That's a big error possibility, right? This is negative 3 times negative 1. So notice that is positive 3. Um, whoa. What am I talking about? I missed a pen stroke here. This is supposed to be a plus 3y. This is supposed to be plus 3y. So that is a big spot for an error, but you're not going to make that error if it's a positive 3. You're going to make the error if you incorrectly write down. That's another possibility of an error. Make sure you write the correct problem down. This was a plus 3. So 4x, and then it's going to be plus, oh my goodness, it's going to be 4x, and then it's going to be plus 6 times x, and then it's going to be minus 3, and that equals 7. This is a 10x minus 3 is 7. If I add 3 to both sides, 10x equals 10 and x is 1. So that's nice. And if x is 1, this top equal, this is so, why did I make this one so easy? Y is equal to 2 times 1 minus 1. So y is 2 minus 1, y is 1. So x is, okay, that's silly. X is 1 and y is 1. So that is the solution using the substitution method. And then finally, the last equation, the last one here is using the elimination method. The last equation that I haven't used yet is this one. Using elimination is not going to be terribly difficult, but it is going to require probably multiplying both parts of that. So let me, you know what I'm going to do? Let me just erase part of this. Now I'll write it down in the space provided. I'll rewrite it. It's good practice because you can see I had a tendency to not rewrite it carefully. So I'm going to try and be real careful here. You're looking at your copy at home. Holler at the camera if I miss it. So I've got a negative 3x and plus 5y equals a positive 30. And I have negative 5x and then minus 3y, and that equals negative 52. So again, I think the y's already have opposite signs, right? It's a positive 5y and a negative 3y. So I'm going to go ahead and just set out to multiply this top equation by positive 3. And I'm going to multiply this the bottom equation by positive 5. That will give me y coefficients that are opposite of each other, right? One will be positive 15y and the other will be negative 15y. And I will be eliminating the variable y. So let's go ahead and rewrite both equations, carefully distributing in the first case a 3 across the 2 terms on the left side and the 1 term on the right side. So when I distribute that across, it's going to become a negative 9x and a plus 15y, and that equals 90. That's the top equation. For the bottom equation, when I distribute that 5 across all the terms, let's see, 5 times negative 5x is going to give me negative 25x and then a minus 15y, and that's going to equal negative 260. 5 times 52, I'm pretty sure that's right. Why am I 5 times 52? Yeah, but one of them was negative, so negative 260. Alright, so at this point we can eliminate the variable y by combining equal things with equal things to get equal things. So negative 9 and negative 25 gives me negative 34. Whoops, let me make that negative sign bigger. Negative 34x on the left-hand side. And on the right-hand side, when I combine positive 90 and negative 260, I get negative 170. And then finally, if I divide both sides by negative 34, I get that x is negative 170 divided by negative 34 is, I get 5. X is 5. Fabulous. So x is 5. Now we just need to figure out what y is. So not quite as clean as it is with the substitution or the equal values method, but I'm going to do this. I'll just use the top equation. I don't know why I'm picking that. It doesn't really matter. But in the top equation, I'm going to solve for y and plug in -3 times, remember we said x was 5, so -3 times 5, check, plus 5 times y, check, equals 30. So we're all set up. Now let's solve for y. This, of course, is -15 plus 5y is 30. If I add 15 to both sides, I get 5y is equal to 45. And if I divide both sides by 5, I get that y is 5 times 9. I get y is 9. So our answer is that x would be 5 and y would be 9 when those two different lines meet up with each other, right? That's, if I was to graph those things, I'm going to see they meet at that point 5 comma 9. Well, that's it. That's all 3 pages of the honors chapter 6 test from 2019. If you have questions, stop by and see me in class. If you see anything goofy that I did during the video that I didn't correct, I would love to hear and know about it. Hope you have a great evening, afternoon, or wherever you're at. Oops, whoa, get back up here. And I'll see you in class.